Just a small caveat first. When we talk about matrices, which we use for instance to represent grids, we identify each element, or in our case, each square, with two indices. The first one represents the row. As this is the vertical component, we will denote it with a Y. The uppermost row will be row 0, the row below will be row 1, and so on. As you can see, contrary to what's usual, increasing Y will be the same as moving downwards. Then, the second index will represent the column, and we will denote it with an X. In this case, the column on the left will be column 0, the next one column 1, and so on. This means that we will use Y's before X's, which is the opposite order as you may be used to. But hey, there's a good reason for that. Having said that, we are ready for the code. For this video, I will not assume that you have any previous knowledge on programming, so I will try my best to explain what's going on here. If you know some programming, but you don't know C++, which is the language that I will use here, don't worry, you will find it easy to translate the code into your favorite language. Our code will start with this function explore, which will just try to explore a single square. Therefore, the only parameter that this function needs is the position, which we will pass as two integers, first the row Y, and then the column X. Remember that one of the things we wanted was to avoid revisiting any previously explored square. We can convert this idea into this single line of code. Let's explain it. First of all, what is this isExplorable thing? This will be a matrix with the same dimensions as the grid, in which each element will represent the corresponding square of the grid. Each of these elements will be Boolean, that is, a true or a false value, to indicate if the square is explorable or not. To be explorable, a square must satisfy two conditions. First, it must not be an obstacle. Second, and this is the most important condition, to be explorable, the square can't have been previously explored. So, at the beginning, we will say that all forbidden squares, the ones representing the bushes, are not explorable, whereas all the other squares will be. However, every time we explore a square, we will immediately mark it as not explorable so that we never explore it again. Now, we will try to explore the adjacent squares. Let's try to explore just the one on the right. We will do the following. If the square on the right is explorable, explore it recursively. A couple simple lines, right? If you don't know what recursively means, don't worry. Wait till you see the algorithm in action. And now, let's do the same for the other squares. If the square right above is explorable, explore it. The same for the square on the left, and for the one right below. As you can see, these lines follow an identical structure, and so we can, and a good programmer would say we must, merge them inside of a for loop. However, for some extra clarity in case you don't know C++, I will write this loop in this equivalent way. This for loop means that we will repeat the last two lines of code 4 times. The first time, the variable I will have a value of 0. The second time, it will have a value of 1. The third time, a value of 2. And in the fourth and last iteration, it will have a value of 3. In case you're not very familiar with programming, bear in mind that we always start counting from 0. So, what will the Y and the X mean here? This will be two small arrays to indicate directions. For example, when I is 0, substituting the first values of the Y and the X, we will be exploring the squares with coordinates Y plus 0 and X plus 1. That is, we will be exploring the position at the right of our square. If you do the same for the other I's, you will realize that we will explore east, north, west, and south, in this order. This naming of variables, by the way, is quite typical in this sort of context, and is obviously borrowed from math, although of course they are not used to talk about differential displacements, as it's usual in the field, but about minimum displacements. So here we are. This is a basic scheme of a depth-first search algorithm. We will end by adding some comments to the code to make things more understandable. So let's recap what this code is doing. We first have this little line that ensures that we don't do redundant work. And then we have this for loop that tries to explore every explorable adjacent square. Just the two ingredients we needed. Just one extra thing that we need to note here. As you can see, this code does nothing special when it finds an exit, and does not check that the square that we want to explore is inside of the maze, which potentially could make the program crash. We will solve this issue later on when we come across it. And now, let's see the algorithm in action.